Numerical number 19 under the chapter Kinematics 3. Numerical number 19. A body covers a distance of 4 meter in third second and 12 meter in fifth second. If the motion is uniformly accelerated, how far will it travel in the next 3 seconds? How far will it travel in the next 3 seconds? This is a straight line along which a body will be moving. The body will start to move from the initial point O, then it will reach to the point A, and then it will be at the point B. Finally, the body will reach to the point C. At O, t equals 0 second, at A, t equal 2 second, at B, the time instant of time t is equal to 3 second. Instant of time t is equal to 3 second. And also we can denote another points, that is D. At C, t is equal to 4 second. At D, t is equal to 5 second. And final point will be E. At E, the instant of time t is equal to 8 second. Instant of time t is equal to 8 second. From the point O, the body started its motion with initial velocity u and uniform acceleration a and uniform acceleration a, and the distance traveled by the body in third second, that is distance traveled by the body in between 2 second and 3 second, is s3. S3 is the distance traveled by the body in third second. Similarly, we can denote the distance traveled by the body in fifth second, that means in between 4 second and 5 second is S5, and S prime is the distance traveled by the body in the next 3 second, that means in between 5 second and 8 second. S prime is the distance traveled by the body in between 5 second and 8 second, that is in the next 3 second after 5 second. According to the question, given quantities are S3, distance traveled in third second is 4 meter, distance traveled in fifth second is 11 meter, and we have to find S prime. We have to find the distance traveled by the body in between 5 second and 8 second. The distance covered by the body, the distance covered by the body in third second, that is in between 2 second and 3 second, is given by S3 will be equal to u plus what? Which equation we have to use, that is S equal ut plus half at square, or St is equal u plus half a to t minus 1. Obviously we have to use the second equation, that is u plus half a to t minus 1, and in place of 2t minus 1 we can write 2 into 3 minus 1, because time t is equal 3 second. Putting the values of S3, we get 4 equal u plus half a into 5, or comma 2u plus 5a equal 8. 2u plus 5a equal 8. 2u plus 5a equal 8, which is equation 1. Similarly, the distance traveled by the body. Similarly, the distance traveled by the body. Traveled by the body in fifth second, that means in between 4 second and 5 second. Distance traveled by the body in fifth second is given by S subscript 5 equal u plus half a to t minus 1, where t is equal to 5 second. Putting the values of S5, we get 12 equal u plus half a 2 into 5 minus 1, or comma 2u plus 9a, 2u plus 9a equal 24. 2u plus 9a equal 24, which is equation 2. So we have these two equations, and we have to solve, and we have to find the value of u and a. Equation 2 minus equation 1, subtracting equation 1 from equation 2, we get 2u plus 9a minus 2u plus 5a equal 24 minus 8 or comma 4a equals 16. Therefore a equal 4 meter per second square. A equal 4 meter per second square. This is the uniform acceleration of the body. This will be the uniform acceleration of the body. This is the acceleration of the body, that means A equal 4 meter per second square. Therefore 2u equal 24 minus 9a or comma 2u equal 24 minus 36 because A equal 4 meter per second square. Therefore u will be equal to minus 6 meter per second. U will be equal to minus 6 meter per second. Now we can return to the diagram. And S is the distance traveled by the body in 8 seconds. S is the total distance. Similarly, S double prime is the distance traveled by the body in 5 seconds. S is the total distance and S double prime is the distance traveled by the body in 5 seconds. So S is equal ut plus half at square, where t equal 8 second equal 8u plus half a into 8 square. So we get 8u plus 32a. 8u plus 32a. S is equal 8u plus 32a, which is equation 3. Or this is the distance. This is the distance traveled by the body. This is the distance traveled by the body in 8 seconds. S equal 8u plus 32a, that is the distance traveled by the body in 8 seconds. Similarly, S double prime is equal to ut plus half at square, where t is equal to 5 seconds. Therefore, S double prime will be equal to 5u plus 12.5a. S double prime is equal to 5u plus 12.5a, putting t as 5 seconds. S double prime, which is the distance traveled by the body in 5 seconds, not in 5th second. It is distance traveled by the body in 5 seconds. Therefore, S prime is equal to, now again we can denote the distance. S is the distance traveled by the body in 8 seconds. S double prime is the distance traveled by the body in 5 seconds, and S prime is the distance traveled by the body in between 5 seconds and 8 seconds. Therefore, S prime is equal S minus S double prime. Putting the expression 8u plus 32a minus 5u plus 12.5a equal 3u plus 19.5a. Putting the values 3 into what? 3 into minus 6. 3 into minus 6 plus 19.5 into 4 equal minus 18 plus 78. Minus 18 plus 78. We get S prime as equal 60 meter. S prime as equal 60 meter. This is the distance traveled by the body in next 3 seconds after 5 seconds. S prime is equal to 60 meter. S prime is equal to 60 meter. That is the final answer of this numerical. S prime is equal 60 meter. This is the distance traveled by the body. This is the distance traveled by the body in between 5 second and 8 second. Distance traveled by the body from 5 second to 8 second.